Okay, over here to the right, we have the graph of y equals the inverse sine of x over 2. And we're trying to find the area of this green region, which is bounded by that curve, the line y equals 0, which is the x-axis, and the line x equals 2. And if you aren't going to do this with a graphing calculator, you have to find the points of intersection of all those curves. And by the way, we have to integrate with respect to y. So we might as well solve this function for x, which I've done over here. If y equals the inverse sine of x over 2, or if y equals the angle that has a sine of x over 2, if I take the sine of both sides, then x over 2 equals the sine of y. So x equals 2 sine y. And to find the points of intersection, when x equals 2, I put 2 right in here, I get inverse sine of 1, which is pi over 2. So the point 2 pi over 2 is this point of intersection right here. And when y is 0, x will equal 2 sine of 0, which is equal to 0. So this is the other point of intersection. So we're going to be integrating along the y-axis from 0 up here to pi over 2. And what we want to do is find an expression for the height of a typical rectangle. That's this distance right here. And this red dashed line and this solid black segment give an indication of how you do that. We want to find the length of this segment. That's going to be this x coordinate, take away this x coordinate. This x coordinate for this particular y sub 1 is 2 times the sine of pi over y. So the point is that the length of a typical rectangle is the right hand x coordinate, take away the left hand x coordinate. And the left hand x coordinate for every y value is 2 times the sine of y. That's this red distance right here. So if I take that away from 2, I'll be left with the height of the rectangle. So there's the height of the rectangle right there. There's the width. It's the number of rectangles approaches infinity. Of course, that width approaches 0. We find an antiderivative with respect to y. That'll be 2y. The antiderivative of sine is negative cosine, so I'll get plus 2 cosine y. And I'm going to evaluate that from 0 pi over 2. If I put pi over 2 in for y, minus put 0 in for y, 2 times pi over 2 is 2. Cosine of pi over 2 is 0. I'm sorry, I don't get a 2 there, I get a pi there. Come on, eraser. 2 times pi over 2 is pi, plus cosine of pi over 2 is 0, minus put 0 in for y, I get a 0. Put 0 in for the cosine of y, I get a 1. 2 times 1 is 2. And I finally get pi minus 2. Okay, that's your exact answer. If I share my screen real quickly, go over to Desmos. There's the integral evaluated, 1.14159. Pi over 2 has the same approximate value. So that kind of proves the point. There you go. Hope that helped. If you have any questions, post a comment.